Alright, so what we're going to do today is something called Laplace. Alright, so Laplace transform. Okay, and it's basically saying that if you have L, oh, this is an actual notation, okay, L, which refers to Laplace, you're Laplacing something, if you like, of a function in respect to t equals a function of t um, equals the integration of infinity as a limit to 0 as another limit, e to the minus st multiplied is the dot, with whatever it was here, in my case ft, okay, by dt. Alright, now its standard form is in dt. They use t's only because in engineering concepts most things happen over time. If it's hydraulics, if it's earthquake, if you're dealing with like stresses and strains and whatnot, you're looking at it over a period of time. So time is always usually what you use Laplace for anyway. Okay, current application, if you could continue. Okay, continue. Alright, anyway, so let's pretend we have an equation like this. Let's make that a t. Let's pretend the equation is, alright, that's a t, yeah? Alright, so dy over dt plus t equals 4, alright? And you're told to Laplace this, alright? What this is actually telling you to do is that you need to produce another equation that each element of this equation has been Laplaced, if you like. Okay, so this has been transformed, this has been transformed, this has been transformed, and then you put it back in the same order, and then that's how you've Laplaced this equation. I'm not recording. Oh, thank God I'm recording. Thank God. Alright, anyway. Okay, so once you've done the Laplace of this, you write it down. Once you've done the Laplace of this, you add it to this original part, and then you make it equals the Laplace of 4. Okay, now the easiest one to start with is 4. Then the t, and then dy over dt. Okay, so that's what we're going to do, because this is the hardest one to Laplace, followed by this, followed by that, and it's easier for you to get the concept from going over the first easy one first. Okay, so note this down, whatever. Let me go to a different slide. Okay, so we've said the Laplace of something. All right, if we use its standard notation, the Laplace of something is e to the minus st infinity 0 multiply whatever it was over here, f of t, and it's integrated in terms of the t, or if it's y, or if it's x, or whatever, but usually it's t. Okay, and that's it gives you an answer that's in terms of s. Okay, so that's the Laplace transform. So if I want to do the Laplace transform of 4, okay, now here's the thing, alright, when it comes to ordinary numbers, the best way about it is to actually find the Laplace of 1. Okay, because trust me, and I'll show you, it's like a little hack, okay, because 1 is always the easiest number to deal with, and because 1 and 4 are just numbers, there's no difference in them except for the number itself, the concept stays the same. Okay, so if I do the Laplace of 1, okay, what I'm saying is it's the infinity 0, alright, e to the minus st multiplied by 1 dt. Okay, is that fair? Now, the complex part here, alright, is this infinity. Alright, this is called an improper integral. Alright, because the integration is occurring over a limit that's going to infinity. Okay, the limit is at infinity. Alright, so what we do to kind of negate this infinity is we say, alright, we're going to place a limit, and we're going to call this limit a. And we're going to assume a goes all the way to infinity. Alright, so it climbs up all the way to infinity. Alright, and that way I can write this, instead of saying infinity, I can say a. And this helps you later on. Okay? And then what we have is, well, I'm just going to rewrite it anyway, minus st times 1 dt. Now, before I do anything, okay, you don't have to write this part over and over again, but I will just for the sake of, putting it. So the limit is going all the way to infinity of a0. Now this part here, okay, well, if I'm wrong, correct me, but 1 times e to the minus st is just e to the minus st dt. Okay, now if we integrate this, alright, if I integrate this part, okay, I'm gonna get 1 over s, obviously it's going to be negative, e to the minus st, okay, and because we set a limit, a to the 0, now you could have written this again over here, but I'm not going to anymore, okay, so what do I have now? I have, okay, wherever there's a t, I'm going to replace with a and 0, so I'm going to have minus 1 over s e minus s a plus, okay, 1 over s, sorry, minus here, e minus s 0, okay. Now, this part's lovely, alright, this part's very lovely, okay. This gives you 0, alright, because this part here specifically, the exponential, is a lot stronger than the 1 over s. The 1 over s isn't going to really do much to the exponential. It's like timesing, like if you times 1 over s by 0, regardless of what s is, it's always going to end up to be 0, okay? Now, because a is going to infinity, alright, a is going to infinity, and s, we're assuming s to be a number larger than 0, okay? So it's going to be a negative number, okay? This relationship with the e is just going to end up giving this whole bracket a big fat 0, okay, which is why I love it, alright? And you'll see this, you'll notice this again and again when we do the rest. Memorize this part. Now obviously this is a bit complicated, it's actually quite complicated, so look at the rules and whatnot later. Now, the next part, well, e to the minus s, well, minus s times 0 is 0. Minus s times 0 is 0. E to the 0, anything to the power of 0 is 1. So I end up with minus 1 over s, okay? Now I've done a mistake, alright? This is meant to be a negative, alright? If you don't know what I've done here, alright, this is the integration rule for limits, okay? When you have an integration, I'm going to write it here. When you have an integration, let's say 2 and 0, okay, and it's like e to et, okay, you integrate it, alright, so that becomes that actually stays et, okay, and you now have to substitute the 2 and the 0, and what you get is e2 minus e0. That's the rule, okay? It's just the rule. So I'm applying this rule here. We put the limits into this equation, like how I put it there, and we get 2 sets of brackets, okay? I just did the mistake, I put plus instead of minus, okay? And I put plus here too, that's a minus, okay? So my answer at the end, let me just take this off. My answer here is, well, plus and plus become positive, so I get 1 over s. Okay? So why did I do this with 1? Well, if you think about it, okay, 1 times est is just est, right? If I had 4, that would be 4 est. And if I integrated, it would be 4 over s. The only difference here, okay, so my answer, alright, pause, write this down, whatever. I'm just going to rub it off. Alright, so my answer was 1 over s. Okay? My answer was 1 over s. So the answer for this is 1 over s. Okay, well the answer for L4, because it's just a number, well, it would be 4 over S. Okay, it's that simple. So L10 is, well, it's just 10 over S, and so on and so forth. Okay, so from our equation, the question I had at the start was dy over dt plus t equals 4. We know that the 4 part, when we transform it, we get 4 over S. Okay, so next one we're going to do t, alright, and this will be a 3-part video. So this is part 1, and then the next part is this next part, and then the next part is so the next video is going to be this one, and then this one. Alright, so